All right, today we're doing something really cool. We're taking a 2,000-year-old idea about cause and effect, an idea that comes straight from ancient Sanskrit philosophy, and we're going to put it through the ultimate stress test. We're pitting it against modern science. Can this ancient wisdom actually hold up? Well, let's find out.
Okay, let's start with a really simple question just to get your brain working. Picture this. You walk into a dark room, you flip the light switch, and nothing. The room is still dark. Now, based only on that, what can you know for absolutely certain? Just hang on to that thought for a sec.
The answer starts with this incredible piece of ancient wisdom from the Vaisheshika school of Hindu philosophy. It goes, Karanabhavat Karyapava. And what it means is if there is no cause, there is no effect. So a cause is necessary. For our light switch, it means if you don't flip the switch, you can be 100% certain that the light won't turn on. That's our first rule. Simple enough.
But here's where it gets really interesting. The second rule is way more subtle. Natu kalyaya bhavat karanapaba. This translates to, but the absence of an effect does not imply the absence of its cause. And this is the real answer to our light switch problem. Just because the light didn't turn on, the effect is absent. You can't be sure that the cause is also absent. The cause, you flipping the switch, could still be there. Maybe the bulb is burnt out or the power's off.
So you see the crucial point here. A cause is absolutely necessary, but it isn't always sufficient. It's not the whole story. And that is the powerful idea we are going to investigate.
So now for the fun part. We are going to put these ancient rules on trial. We'll run them through the philosopher's test, the engineer's test, the logician's test, and finally, the ultimate test, the mind-bending world of modern physics. Let's see if they crack under the pressure. First up, the philosopher's test. Let's dig into the very foundation of how we even think about cause and effect. You know, Western thinkers have been chewing on this for centuries. The brilliant philosopher David Hume, he basically came to the exact same conclusion as that first sutra. He said that a cause has to make a difference. In his words, if the first had not been, the second never had existed. The best way to wrap your head around this is to think about the difference between a necessary condition and a sufficient one. For example, air is necessary for life. No air, no life. The absence of the cause, air, guarantees the absence of the effect, life. That lines up perfectly with Sutra number 1. But is air a sufficient condition for life? No way. You also need water, food, the right temperature. The point is, just having the cause, air, doesn't guarantee the effect. And that's exactly what Sutra number 2 predicted.
Okay, let's switch gears. How does this ancient logic hold up in the world of engineering and complex machines?
Well, in engineering, there's this fundamental principle. It's called zero input, zero output. It means if you have a system that's just sitting there and you don't put any signal or force into it, no cause, you're not going to get any change out of it, no effect. It's a perfect modern-day echo of that first ancient rule. But, and this is where it gets really cool, what if the causes are kind of hidden or perfectly balanced? Just think back to high school physics for a sec. Imagine an object, right? You've got two forces pushing on it from opposite sides, perfectly equal. What happens? Nothing. The object doesn't move. The effect, acceleration, is absent. But the causes, those two forces, are very, very real and active. So once again, an absent effect doesn't mean there's an absent cause. Sutra number 2 holds up again.
All right, let's crank up the rigor. It's time for the logician's test. Can these ideas survive the pure, cold, hard rules of formal logic and computation?
So let's look at this like a simple AND logic gate, like in a computer. The effect E only happens if cause C and another factor D are both switched on, both a 1. Now, in the first 2 rows, notice that if the cause C is 0, the effect E is always 0. No cause, no effect. Sutra 1 confirmed. But now, check out that third row. The cause C is present, it's a 1, but because that other factor D is a 0, the final effect is still 0. This is a perfect logical proof of Sutra 2. Having a cause does not guarantee you'll have an effect.
And, believe it or not, this translates perfectly into the formal language of logic. The statement, not C implies not E, is always true.
That's just a fancy way of saying no cause means no effect. But the reverse, not E implies not C, is not necessarily true. An absent effect doesn't logically prove an absent cause. This ancient wisdom is perfectly sound logically.
And now for the final boss, the ultimate test. We're taking this 2,000-year-old idea and throwing it straight into the deep end. The absolutely mind-bending, counterintuitive world of modern quantum physics.
And I'm not kidding when I say this. At the quantum level, our normal, everyday ideas of cause and effect just get weird. Really weird. See, in our big classical world, we think of a simple, straight line. Cause leads to effect. But in the quantum world, it's not a line. It's more like a web of probabilities. An initial cause doesn't lock in one single effect. It just determines the likelihood of a whole bunch of different possible effects. It's fundamentally built on uncertainty.
And if you thought that was strange, get ready for this. There are actual experiments with something called a quantum switch that have shown a single particle, a photon, can experience two different causes, A and B, in what's called a superposition of orders. What on earth does that mean? It means it experiences A then B and B then A at the exact same time. The very rule that a cause has to come before an effect, it just starts to dissolve. So you have to be thinking, right? In all this quantum chaos, surely these ancient rules finally break down. But here is the most incredible part. Nope, they don't. Both core principles still hold. Fundamentally, if there's no quantum interaction, no cause, the system's state won't change. No effect. And because everything is probabilistic, seeing no change, no effect, definitely doesn't mean that some cause or interaction wasn't there. So, let's recap. What's the final verdict? In philosophy, a cause is necessary. Check. In engineering, zero output doesn't mean zero input. Check. In logic, an effect implies a cause, but not the other way around. Double check. And even in the weird world of physics, no interaction means no change. Check. The two ancient sutras survived every single modern test we threw at them. I mean, just let that sink in for a second. A piece of logic, 2 millennia old, that holds true for everything from a simple light switch all the way down to the quantum foam that makes up reality. It really makes you wonder, doesn't it? What other profound truths are out there, hiding in ancient wisdom, just waiting for us to rediscover them?